Hello, everyone. Uh, Now we're going to talk about CRM or customer relationship management. It's obviously a very popular discipline. Probably the leader in this industry would be Salesforce, but it's a way to track and get every relationship about a customer. It's more focused on just that, the relationships, the interactions with the customer. So that's in many different ways, emails, phone calls, visits, whatever it might be. That's what it focuses on, how you interact with your customer. Um, the one thing about customer relationship management is it can be significantly different based on the industry or the organization. And the organization itself can have many different type of relationships based on the size. It can have situations that one type of industry has one type of relationship with a customer, another type of industry that the same company has a completely different relationship with that customer. So it's not just unique within an organization. It can have multiple different relationships within an organization. So customer relationship, with all those reasons and some we're about to talk about, makes this a very complex uh, item to model in the data warehouse and in business intelligence. The objectives we'll talk about is the customer dimension attributes. You'll see in here that the customer dimension attributes are significantly more than other dimensions we've talked about up to this point. There's the amount, the variation of the type of attributes, and all those type of things make it very challenging for the customer. We'll talk about bridge tables for multi-value dimensions and other options besides bridge tables, but why bridge tables are one of the better ones we'll talk about. We'll talk about how complex the customer behavior can be, how the relationship with the customers can be multi-levels, multi-level. You can have a customer who's also a producer for you. You can have a customer who's also a competitor of yours. So there's a very complex situation with customers in that relationship. Then we'll talk about the data integration approaches of how to handle a customer and all the different elements of that. And then finally, we'll talk about the low latency reality check and how that plays itself in the data warehouse and the modeling and the BI solutions you come up with CRM. The conform dimensions for CRM. We talked about conform dimensions earlier in the book, and the customer dimension is often the most challenging, the most difficult to put together in a data warehouse and a BI platform and to deploy it. One of the things is just the pure number of attributes that you can see with the customer. A lot of dimensions can have 6, 8, 10, even up to 20 attributes potentially about those dimensions. But when you start talking about customer, it's not uncommon to have hundreds, if not nearly thousands of different attributes that you have on a customer. You're going to care about where they live, how often they shop, the type of payment they use, whether or not they are price sensitive or they're someone that needs to be reached via ad or other kind of reality. Are they social media active? All those type of things are attributes that you need to have about your customer and makes it complex. Another thing about the dimensions and the attributes for a customer that makes it very challenging is the very fact that the customer dimension is sourced from many different places, both internally and externally. The internal systems can come from things like point of sales, marketing systems, billing systems, and external sources can come from all kinds of places, including government sources, different agencies or organizations like credit bureaus, and to take that data and for those very different systems, both internally and externally, and to bring those to munge those together to get a clear and cohesive model of your customer and put those in dimensions can be very challenging and creates quite a bit of complexity in the world we do it. Um, Both with the customer, both the way they're named and the address that we have with uh, our customers can create a lot of challenges. Internal systems themselves quite often do not store addresses the same way. They will store addresses slightly different. And just the fact the way that we enter the systems, even if they're set up on the systems very consistently if the way we put it in is not governed and not controlled. It's a simple thing like 21 East First Street can have all kind of complexities. You can have 21 spelled out. You can have the numbers 2, 1 with ST after it. You can call it first. You can abbreviate it. You can have 1 ST. There's all kind of complexities in how we do that and how to make sure that we look at those as one entity instead of multiple entities. When you bring in the fact that you have external systems, as I mentioned before, whether it be government census data or tax locations, whatever it might be, include that with social media and things like credit bureaus. You're going to have all kind of challenging ways to make those same physical locations meld together and look together. When we start talking about international, that makes this situation even more difficult. As you know, in the United States or in the Western world, we basically have a first name, last name with a prefix and a suffix. So maybe you have Dr. or Mr. or Mrs. or Junior or other type of things you can put out there. But when you talk about international, there's significantly different ways people are use their name and how they're named. And also, when you start talking about addresses, again, a real significant difference. Obviously, in the United States, it's your street, your city, your zip code. All those things are consistent. When you start talking about international addresses, that can get significantly more complex. We also have to deal with customer data considerations, and one of those might be that the date attributes that are there. We care about a lot of things in our interactions with our customers. Things like their first purchase, their last purchase, their date of birth, the last time we've contacted them, whether that be on a service call or a visit that they didn't purchase something. We care about all those things. Each time that date has a set of attributes in about itself that we want to capture. And quite honestly, that sometimes can be challenging. So snowflaking can be a way to utilize the capture of this needed elements of dates. If you take a look on page 239, they do a nice job of they call it the date dimension outrigger as a way to be able to handle the complexity of doing the dates for the customers in the multiple different ways we want to track dates with that customer. And again, look at those and realize, again, this is, as you're seeing, I think, that all the different complexities we have here make the CRM a very challenging model for the data warehouse and business intelligence in general. We'll talk about segmentation attributes and even scores for the customer. Classifications of the customer into very distinct segments are very often very powerful, especially when you start talking about things in machine learning and in data science and artificial intelligence. You care about how you the segments you put in your customer. You can call them frequent shoppers, high impulse buyers, whatever different measures you have, or seasonality systems that you have there. Those are things that are very important when you're trying to analyze your customer. And quite often you'll use aggregated facts as a dimension attribute in itself. For example, you'll look at how much a customer spends, when a customer visits your location, whether it be online or in person, how many different items that customer usually goes after. Are they coming in and buying specific things, or do they buy your whole scale across your whole spectrum of your products? So those are all segments that you're going to want to have, and they can be attributes about that dimension in itself. We'll talk about the behavior tag time series, known as also as RFI, and by that the RFI is obviously spelled there below. It's the recency. When's the last time that customer was here? Frequency. Is this a frequent customer? Does he come in all the time, or is this, he's a 3 times a year customer? And the intensity. How much shopping? How much does he buy? How much of our product is he consuming? These are all things that you're going to care about significantly as we talk about the segmentation of the attributes and the scores around customer. Customer hierarchy can be a very tricky thing to deal with. They have quite often a nested hierarchy, so especially commercial customers. Like I said, sometimes a customer can also be a vendor. Our customer can also be a competitor. Within that customer, they might be a customer in multiple different ways with us as an organization. Some hierarchies are very predictable, very cut and dry, and we like those. Those are easy to model. Those are easy to do things on. A lot of them, though, are what they call ragged hierarchies. It's a structure that would normally assume to be a parent level, and you have multiple of those. For an example, that would be a salesperson, the hierarchy for a salesperson. You may have two top level aggregates. You might have a foreign and domestic. That one salesperson might roll into both. So that complexity that you have there makes that more difficult to deal with. So you need to be aware of how that is done and how that's handled within the modeling of your data warehouse. When we talk about multi-value dimensions, up to this point, most of the dimensions we've talked about have been single value. We're going to start talking again CRM, specifically a customer. There are many multi-value at the grain of transaction. For example, we might care about our customer, the number of hobbies an individual have. It could be that they are sports fans, they are visitors to the arts, or if you're talking in the situation of medical, how many symptoms does a patient have? Do they have 1 symptom, 4 symptoms, 10 symptoms? And what category is that customer? Are they a builder? Are they an architect? Are they a supplier? Are they a contractor? Are they a consultant? All those things that we care about, and we have to deal with the multi-value for that dimensions and make it easy to pull back to see that information for our analysis. So you have basically 2 options when you're talking about the multi-value. You have what they would call the positional design. You create however many columns you think should handle that. You guess how many hobbies a customer might have or how many the max customer might have. For example, you might say, I'm only going to track 5 customer hobbies. And that may be fine. But if you're in a medical situation and you guess that 10 symptoms is all they're going to have, and now they have 20 symptoms, how do you handle that? And what's the right number to guess? So while it's nice and neat to have the positional design, it creates a lot of potential problems. And has some real limitations, and it doesn't scale very well. What do you do when all of a sudden you decide that no, you've got to have more? So what do you do with all those previous records that didn't have those in there? Now you expand to that. The other option you have here is what they call the bridge table approach. It removes any kind of scalability concerns, and it's scalable quite honestly to any size. So if you decide that you want to keep 1, 2 to 1,000 records about a customer, you can, and it's only going to store what you capture. Unlike the positional design, if you decide you're going to store 10 things about a customer and you only store 3 things, you have 7 items that are null or unused. In a bridge table approach, you literally will only have the number of attributes that you capture for that relationship, and it works out to be much more efficient. Now, the negative might be that this table design requires more complex query to return the values, something that the average Joe user sometimes struggles with. And that's because those questions, to get that information back, becomes a complex way to handle a complex SQL query versus a very simple one. In fact, many BI tools struggle with that to visualize as well. Now, Tableau and Power BI, for example, are 2 that have done a nice job of starting to be able to handle this complexity, but it's still an issue because it's not as simple, as straightforward as others are. And when you're ever trying to run those those complex queries, one of the keys about that, and no pun intended, is to capture the key in the table of the customer or product that is being analyzed. So if you have that key value in there, you now can relate that back and makes things much easier. The use of the study group concept that they outline on page 250 for the dimension table is really important to understand. So I spent some time going over that section to understand that what the study group dimension table does and what it provides for you. So the customer data integration, you either have a single customer dimension or multiple customer dimensions, and they're tied by conformed attributes. Similar to the conformed dimension, it's a conformed attribute. Many companies are lucky enough to have a master data management system, or a lot of times you'll call them the MDMs. It helps you create that one single enterprise view of your customer because it takes the different inputs from systems and it requires them to be formatted to put to one view of that customer. It's Not a lot of companies do. I shouldn't say that. There are many companies who don't have an MDM. And even if you do have an MDM, it's not a simple discipline to install and maintain. For example, you've created your MDM, you've got all your things you want to capture about your customer, and now you decide to purchase another company or another area of an industry that you get involved in, and there are new elements there. So now you have to retrofit your MDM system to handle that. And what do you do with the existing record? So while it's a very important feature, it sometimes is not an easy thing to keep and maintain. You'll see that when you're trying to match that customer from disparate systems, it can be very difficult. That science can be more complicated than you might expect. You know, I mentioned before about address, but there's a whole bunch of things also in the customer. Recognizing that customer, because he may come as 3 different names. For example, you know, you may have, and I'll pick the company I work for, Kroger. We have the Kroger company, and we used to have something called Turkey Hill Dairy, which was a division of Kroger's. So when people would see that, they would never associate those automatically with Kroger, but yet for someone that was a customer or a supplier to us, we are one and the same. We were paid from the same till. We have a lot of the same organizations. So those complexities can make it very difficult to run the data science you need to do against your customer. And finally, we'll talk about the low latency reality check. One of the things they've talked about is that, you know, you're going to hear that more real time the information is, the better it is. So the more up to time, real time you have, the need to get that social media Twitter feed out almost immediately, how important that is. The reality is when you have a situation where maybe you're only getting a daily feed, chances are that most of the transactions you're looking at will have been completed or put in a state that can be recovered. If you're getting almost real-time data, sometimes you're looking at partially completed transactions. Maybe an item will be added or deleted from that transaction. Maybe a new payment type is added or changed and it conflicts. So you need to be very careful, because by having that low latency out there, you can end up causing yourself a lot of quality issues. And that can really throw off the data you're using to do your analysis and your science on. And more importantly, sometimes it can challenge people's belief in the quality and the truthfulness of your data. And when people are doubting that, then the effectiveness of your warehouse and the effectiveness of business intelligence solutions suffers greatly. The other chapter that we're responsible for this week is to talk about the life cycle, and I think it's very important. We won't have a specific lecture on that, but it's very important that you understand that life cycle of both the data warehouse and the BI world, so that you can understand that it's not just a one-time thing. It's something that takes care and feeding. You have to be very prescriptive in how you're doing that to make it effective. Thank you.